I'm going to do a moderate example with the root and the ratio. So first I will use the ratio, I guess. So an plus 1 is n plus 1 cubed over 4 to the n plus 1. And an is just n over 4n. So I take the root limit, I take the ratio limit, rho, lem n goes to infinity, an plus 1 over an, since everything's positive, the absolute value equals the series. So I get n plus 1, 3 over 4n plus 1 over n 4 to the n. So this is a mashup of a divergent p-series and a convergent geometric series. Let's see which one wins. So invert and multiply. Oops, it's in cubed. Like I like to do, I like to gather like terms. (4n over 4n plus 1). That's going to be equal to this limit. Like power, a over b to the 3 equals a cubed over, b cubed. So I can write it over single power, n plus 1 over n cubed. This is going to be 4n minus n plus 1, if you want to do it that way. Actually, I think it makes more sense to do it this way, 4n plus 1 minus n. Just had a stupidity instant there. So in other words, subtract that. Lem, n goes to infinity, 1 plus 1 over n cubed times 1 over 4. Well, this is going to be, this goes to 0. So I get, this is equal to, this is just 1/4, so I get 1/4. Rho is equal to 1/4. Therefore, by the ratio, the series converges absolutely. Okay, a lot of work. Let's do it with a root. That's my root limit. That's going to be the limit. N goes to infinity. N cubed over 4 to the n, 1 over n. That's equal to the limit. N goes to infinity. N over 3 over n. Okay. I think it's overcomplicated that. We'll fix that though. Over 4 to the n over n. This is going to be limit 4 on the bottom. This is going to be the limit n to the 1 over n cubed. Sorry, I switched the 3 there. So this is going to be limit n to the 1 over n cubed over 4. That's just 1 over 4, and that's just going to be 1/4. So by the root, the series converges absolutely. So the root is much quicker than the ratio. 2 points, 1, you get the same number as I mentioned in class, no matter which test you use. And the root is really generally the simpler test. The only time you really want to use the ratio is when you see these exclamations. You're like, ha-ha, I get to use the root. Sorry, aha, I get to use the ratio, because there's an exclamation. Sorry, that's silly. Okay, that's it.